Hello everyone, today it is question 8 of application of derivative miscellaneous exercise. If you want to solve this question, take your book and pen and let's do it together. So the question is, find the maximum area of an isosceles triangle which is inscribed in an ellipse. So let's take first ellipse. Okay, so let's take an ellipse. Now I have drawn the ellipse. It says that the isosceles triangle should have its vertex at one end of the major axis. So one of the vertex of the triangle we have taken at A. Because it is an ellipse, because it is a triangle inscribed in the ellipse which is isosceles, it should have one of the part above the x-axis and another below the x-axis. If we have taken A as the vertex, if B would be the vertex, we could have taken one part in the left side of y-axis and another to the right side. So I have taken this kind. You can take it in many different ways. See that, but only one vertex is the vertex of the triangle. Now we want to prove that it has maximum area. So we will have to find the area of this, wherein we can say that it is altitude is AM. So we can use the formula half base into altitude. For that, let's find out the coordinates of B and C. Now, okay, we have already taken B here, so let's take this as D. Let's take the coordinates let's find the coordinates of D and C. Now we'll write D is say x comma y, and this is minus x comma y. So the length of DC is 2y, and what will be m? M will be, because it is on the x-axis, it is x comma 0. So we have AMS, this length is x and this is a, so it is a plus x. So the altitude is a plus x, the base is 2y. So now we are going to find the area of the triangle ADC, which is half base into the altitude, which makes the area as half into 2y into a plus x, which is y into a plus x. Now we don't want two variables. So what we have to do is, from the equation of the ellipse, let us find what is y and replace it over here. So find y square upon b square is taking x square and a square term on the other side. This is what we get for y square. So what is y? b by a root of a square minus x square. So we'll put this value here. So this can be taken as a function in x, or else we will take the square of this. Solving the square will be easier. So we will take f of x as square of this term, and when we are finding the area, we will again take the square root to get the area, because over here you are not simply supposed to prove it as maximum, you also have to find the area. Okay, our function is square of this So we'll simplify this a bit. This is a minus x into a plus x, so it becomes a plus x square into a plus x, that is a plus x whole cube. Now this is our function, and as we know, for maximum and minimum kind of questions, the first step after finding the function is to find f dash x. So let's differentiate this. B square upon a square is constant as it is, using u into v for this one. So on applying u dash v, you see the derivative of a plus x, a minus x, a is 0 and minus x is minus 1, this term as it is over here, and same way the first term u as it is, derivative of a plus x whole cube, which is 3 into a plus x whole square, and then again derivative of a plus x, which is 1. Now we need to simplify this, and we can see that a plus x the whole square is common. What is left here is minus 1 into a plus x, which becomes minus a minus x, 3a minus 3x. So the simplified form of f dash x is this. You may take 2 common. So this is our f dash x. So obviously we have to find the critical point. Equating this to 0, the first thing is x is equal to minus a, which is not possible, because if it is minus a, then we have 2 vertices as the vertices of the major axis, which is not possible. So that won't come. Going to the other one, 2a minus 4x is 0, and so our x value is a by 2. This is our critical point. Now to look for maximum, let's find f double dash x, once again using u dash v plus uv dash. Derivative of this is 2 into a plus x, and again derivative of a plus x, which is 1, plus a plus x whole square, and derivative of 2a minus 4x, which is 2a constant minus 4 into 1. So that is minus 4. Now if we see, this term is going to become 0 because of 2a minus 4x, from where we have got the critical point. So only this one, which is b square upon a square into a plus x whole square into minus 4. Now this is a term which has minus 4, or it is going to be, the product is going to be negative less than 0, and that brings us to the maximum area. So that shows that the area is maximum. To finding the area, now we already know the critical point is a by 2. Let's put it in this one or in this one, wherever you want to substitute it to get the area. So we are going to substitute it in the directly into the area. This is b by a root of a square minus, what is the value of x? A by 2. So x square will become a square by 4. So we have b by a, simplifying this it becomes 3 root 3 ab upon 4. That is the area of the triangle, say square units. I hope you have understood this question. The other word problems will be taken up in the coming videos. Thank you and see you again.